that the unit that JJ is a part of, the cloud, the hybrid cloud, the combination of IBM Cloud and Red Hat is really going to be the growth engine of IBM in the future, which is why they created or will create this separate unit on just services alone. So I think it's indicative of the growth in JJ's business, the tremendous acceptance of IBM solutions in the marketplace, all yours.
Perfect. Well, thank you, Ron. That was a wonderful introduction. Yes, hi everybody. My name is JJ Asgar, and I'm a developer advocate for the IBM Cloud. And as just Ron said a moment ago, I am very interactive. I'm expecting people to ask questions or thoughts, and from what I've seen so far, I'm going to go through a lot more of my beginning stuff much faster so we can get to the code and actually see what's going on. I really do have that email address of awesome@ibm.com. You can directly reach me there. If you know anything about IBM, getting something like that is Herculean, and I like to make sure everyone knows that I have it. I'll be looking over to the right just to see the chat, but I am speaking to you just because I really do like to see if people ask questions or anything like that. And finally, if you need to find me on Twitter, at JJ Asgar on Twitter, which is usually the best way to get a hold of me if it isn't through email. Okay, so I'm going to talk about Kubernetes and COBOL as a science experiment that I did. And also, I'm going to be mentioning OpenShift. Kubernetes and OpenShift interchangeably. If you don't know, OpenShift is Kubernetes, just with a lot more stuff on top of it, which I will talk about at a greater length in a little bit. But I will say Kubernetes and OpenShift back and forth, but I will make sure when I do say OpenShift, it is specific to OpenShift, I will make that known. Okay, so I'm a very technical guy, so we're going to have some fun with some code and some technical things too. So let's get at it. There we go. So the agenda. We're going to talk about the overview of Kubernetes and OpenShift to make sure we all have the same vernacular. As I've seen so far from some of the other presentations, we've been through a lot of this already, so I'm not going to spend a lot of time on there, but I want to make sure that if you are just joining now or just popping in, you at least know the scope of what we're talking about. Then we're going to talk about some cloud-native application development terminology to kind of level set a little bit more. Why this project is important, because it's actually very, very important to kind of see the scope of what happened here. And if I have time, I'll talk about how I actually came and brought it together, which is kind of a fun story. But the main bulk of what I want to show, which is actually very pretty straightforward when we actually get to it, is building a basic ETL pipeline with Cobalt on Kubernetes. If you don't know, ETL stands for extract, transform, and load. That is the 95% of the COBOL applications out there. When you look at COBOL as a large thing, especially if you're coming from the cloud native side, which I am, I had to actually learn what an ETL pipeline was. So, you know, yay. But it's wonderful. It's wonderful to see how what is old is new, what is new is old is all over again. And yes, again, I want to reiterate, please ask questions, bring these things up. I am all about getting interrupted and answering the questions that you have about this. So bear with me for 1 second. Of course, I'm already starting to cough because I'm speaking, but you know, that's life. Okay, let's talk about some building blocks. And again, I'm going to go through this very quick, and these slides are available after the fact if you do want to reference them later. First thing first, everything's built off of something called a container inside of the cloud native ecosystem. We all understand this. Nice little fun little tidbit of information up in the right-hand corner. That should be the Docker logo, but I've been recently informed by my marketing team I'm not allowed to show the Docker logo. So in other words, I am an old man yelling at a cloud right now. Everything is built off of the container, which has multiple offerings. There's different ways of doing it, using Podman or Docker or Builda or Kaneko if you're in the GCP world. Everything adheres to something called the OCI spec, which is a standard spec for all containers. You need some type of registry to store your container. Docker Hub, Quay. There's even a registry built inside of OpenShift that I won't be showing, but it is there. Everything's built from something called a Docker file. And it is the beautiful story that when your developer has written an app, they can containerize it and say, it works on my laptop, and any container runtime out there, it will work on that. So as long as you have the container runtime, you can run any container. Now, as you start building out your microservices-based architecture, you need some way to orchestrate all those containers, and that's where Kubernetes comes into play. Kubernetes is, as we all know, is a container orchestration. It's open source. The most important thing to realize is that there are offerings like IBM Cloud. Just saying, there might be one at IBM Cloud, where we do offer a Kubernetes service for you, so you can just consume it. But the most important thing to know about it is that it is a very core framework, and it is just a way to run containers. So when you start looking at the ecosystem of Kubernetes, that's the reason why landscape.cncf is so large and so scary, is because Kubernetes just is an orchestrator at the core of what it does. It is a really good one, don't get me wrong, and it's an amazing framework to get it, but the ecosystem requires so much more. And Kubernetes specifically is just the orchestrator. You take it one step farther, and that's where OpenShift comes in. OpenShift is the production-grade open source Kubernetes offering from Red Hat. The most important part is that there is true enterprise support. So if you are an enterprise trying to figure out a way to move to cloud native, spending your time looking at OpenShift is a very valuable thing, because you actually get the developer velocity that you want from your developers in a very guardrailed kind of way, where all of a sudden, with a handful of commands, you can get new versions of your code out in a rapid fashion. It's a little bit farther out of scope than this presentation that I have now, but I do have a fork of all the code I'm about to show on vanilla Kubernetes that works on OpenShift also. And please, if you are interested, reach out to me, and I would love to have a longer conversation with you about it. There are strong opinions in OpenShift, but they are some of the best opinions to make life significantly better for your developers. Okay, so let's just talk about some very basic terminology to kind of build up to where we're going to do to make sure that we all understand where the code comes in. So I said originally everything's built off of something called a container. Well, actually, that's a lie. Everything that Kubernetes and OpenShift knows about is actually something called a pod. So if you see here, you see Kubernetes and OpenShift all at the bottom. There are multiple different pods here, pod A through E, where pod A has 2 containers, pod E has 1, pod B has 3, and these are the smallest entity that Kubernetes to say, I need to run this. So in this case, there is 2 pod A's. You take that one so farther, you create something called a deployment, where you're telling Kubernetes, I need N number of pods. N can be any number of pods you have up to the extent of your compute capacity. So in this case, we have 2 pod A's where we have 3 nodes here, which I'll talk about in just a second, where I will always make sure that there are 2 pod A's running somewhere in my Kubernetes cluster. The beauty of deployments is as soon as something breaks, i.e. the middle node blows up, or some problem on the far left node there, as soon as Kubernetes notices that it's gone, it will spin it up somewhere else. So as you see here, because we only have 2 pods for pod A, it spins up the second one. Pod B had a deployment replica default of 1, and it's like, oh no, it broke. I need to spin it up somewhere else. It goes ahead and throws it over onto that far right location. Deployments are quintessential to how Kubernetes works and how you talk to Kubernetes. There is one little thing that you should also know when you're starting to learn and understand the Kubernetes ecosystem, is that Kubernetes, when you boil it down to then the orchestrator, as a consumer of Kubernetes, you are talking to an API that talks to compute. At the very core of that narrative, the narrative of Kubernetes is, as long as I take my pod and say, hey API, run this somewhere, that is what Kubernetes does. So it's an orchestrator that is an API to compute. If you can get that seed in your head, all of a sudden a lot more of Kubernetes starts making a lot more sense to you. I mentioned a node a moment ago, and so a node is just something that runs something called a kubelet. So it can be a laptop, it can be a VM, it can be bare metal machines. What I'm going to show is the VM instance in just a moment. But as you see here, there are multiple nodes in this diagram. But to us as consumers, we only talk to Kubernetes and OpenShift. So we don't know where it runs. So the idea of having a VM that sits on some ESXi host inside of your data center or whatever, that you're like, we don't know what this does, we can't delete it. Kubernetes takes all that away from you and just gives you a direct API to compute, and it orchestrates and figures out where things need to run. Okay, so let's talk about some internal concepts of Kubernetes and OpenShift to make sure that as soon as I bring up the code, everything falls into place. Because we're all engineers, right? We're all engineers. We all need DNS. Well, of course, Kubernetes has DNS. It's called kubedns, and it's internal. And that's how you get the different pods, because they don't know where each other run. There's a way to declare something called a service where you say from pod A, I need to find foo web. You created a service called foo web, and it knows that pod C is where it's at. Where it's at. Now, this is a very basic example, and I'll build up off of this. There's something called a node port out there, which was originally designed as a debug way, where you say this service of foo web on port 80 hits that specific pod at port 5000. Now, node ports are designed for debugging, but people have been putting them into production for other things. I strongly suggest using other options than node ports, but they do exist, and you will see them. But it goes directly to that one pod. The reason why this is important is because you can have n number of C pods, right? So you can have C1, C2, C3, well, they're all named C, but you get the point. Where if you have a node port that ports directly to that C1, if you have C27 over there, it will not go to that node port, because the node port won't go to that. It'll only go to that C1. If it gets a little bit more complex than that, and I realize there's wide swaths of statement there, but in general, when you're getting your head wrapped around it, that's important to know. Next, I believe the gentleman before me mentioned namespaces, which is also a really powerful tool inside of Kubernetes. It is the way you create walled gardens inside of your Kubernetes cluster, so you can have the exact same design for your application in two different workplaces on the same hardware. This is important because remember all those jokes about being a dev and you're like, well, it works on my laptop, now we're going to put it into staging. Staging kind of looks like production, but it has like old hardware underneath Jane Doe's desk over there. And then we take it and we push it into production, and it's a completely different machine in a data center somewhere with all these resources. Oh, it turns out we have problems because of X, Y, and Z. Well, using namespaces to cut up your Kubernetes cluster into dev, staging, and prod, for instance, you can take a direct carbon copy of your manifests and pop it into each of them, where one namespace has GPUs or whatever inside of it, which allows you to use the same hardware, the same process to get through, and everything sits inside of the cluster how you expect it to. Now, I do want to say that there are ways that people have extended namespaces to be able to get across for different things. That's out of scope for this conversation, but in general, if you are just coming into this world, namespaces is a way to create a walled garden. Take it one step farther, and that's where OpenShift actually is really super powered namespaces. They have things called projects inside of it. Now, if you imagine me being a developer here in the center and I only have access to payment dev, projects are designed to be, in essence, Git branches. If you know anything about Git development, creating a Git branch, they're supposed to be ephemeral. You do your work on some feature branch, and then you merge it back into main or trunk or whatever you call your main thing. Same thing with projects on OpenShift. When you start building up your projects, you iterate and you're like, well, payment dev 1, this does this. Okay, it's kind of what I wanted. All right, let's throw that, let's merge this into production again, and then let's go into dev-2 to see and iterate over and over and over again. It really does create some great, powerful things to give the velocity of your developers the advantages they need. Again, this is specifically to OpenShift, but it is unbelievably powerful if you start focusing on that story. And again, you have ways to isolate users and groups, and with very, very strong RBAC. In this case, obviously, this person only has access to payment dev, but they do know of the other projects in case they do need to talk to someone, et cetera, et cetera. So when we're talking about load balancers, so when we were talking about node ports earlier, the one that you should look into if you're playing around in Kubernetes is something called a load balancer. It's just like your old F5 load balancer or whatever you have, just software-wise. It is unbelievably powerful, but it is smart enough to be able to do some very basic work for you to be able to load balance across all your different C pods in this case. It's super powerful. There's a lot of knobs and dials to it. You can even rip it out and put in other options. There are third-party load balancers that you can run. But if you are looking into this ecosystem at all or have trying to understand it, load balancers are the way to go. Not node port, it's load balancers. But take it one step farther, there's something called an ingress. And ingress is the hardest concept to really kind of get your head wrapped around when it comes into how Kubernetes works for intercommunication of pods when things come together. In this case, this is a really bad, simple example of creating an ingress rule for foo web to talk to foo data. So if I have this, if you can see my mouse hopefully, if I have that pod C here, where this is my web front end, and my data end is called foo data, when I be coming in from the outside directly here, I will hit the foo web to talk to this. But if I need to do a get or a REST call to foo data, this doesn't go out and come back in. It's smart enough because of the path that is created inside of the ingress to foo data to pull the data from this data plane or whatever it is. This is really important to understand because with vanilla Kubernetes, you have to build this all out by hand. The joke is that Kubernetes developers all become, or consumers or admins become YAML engineers. Because as you can see over here on the left-hand side, it is all YAML. And you spend a lot of time playing with YAML, but it's good to know. This is where one of the most powerful things that OpenShift has is something called routes, which they've been able to wrap up all that pain point of ingress and how ingress works into literally 2.5 commands that automatically get done via OpenShift. For your developers to do a red-green deployment of a microservice or some application, it can be all done automatically and all magically to be able to make that thing happen. So they can focus on writing the code. Very, very valuable. I wish I could show more about it, but again, I want to just show vanilla Kubernetes and Cobalt, which we're about to see in just a second. So let's talk about the ecosystem. Just so when people do mention these things inside of it, people kind of know what they are, because names are hard, and it's sometimes you're like, what is that thing? I have no idea. Well, this will give you a quite quick little jump through, so at least you understand where they fit in. First thing first is something called Helm. If you've never heard of Helm before, the easiest way to describe it is a package management system for Kubernetes. I know it's not, but it is the kind of the default, become the default community way to package applications to run them on Kubernetes. Helm charts are very, very powerful. There's some really, really neat ones out there that do some amazing things that are production grade. So when you hear Helm, think of a way to deploy an application in a repeatable day one, day two way to get it onto Kubernetes. Istio is something called a service mesh. That is very much out of scope of this conversation, but a service mesh is a way to do more intelligent routing and visibility into your microservices-based architecture. There's a lot more to Istio, and that could be its own talk, or for that matter, its own afternoon. It is very, very powerful and amazing. And because IBM is a big part of it, it's pretty cool. Just saying. Hopefully somebody giggled at that. Hopefully. We'll see. Next, something if you've ever heard is called Knative. Knative is the serverless-based framework on top of Kubernetes. So when you are talking about the AWS Lambdas out there or any of that thing, Knative is a way for you to run serverless functions on top of Kubernetes. It is moving extremely quickly. It is unbelievably powerful. It is, again, a talk inside of itself, or a conference inside of itself, to be honest with you. But if you do want to look down that serverless path and you want to have everything internally, like on your own hardware and things like that, Knative is one of the ways to go. Okay, so after all that, let's talk about some Cobalt. So hopefully we can kind of see how everything kind of comes together. And we are going to talk about what people normally think about Cobalt. Usually some guys in some suits clicking some buttons in a data center, a lot of green and red text. You know, that's kind of what goes on. Like, you know, there's those people in the data center that do these things, don't really understand it. You know, that's what people think. Well, it turns out it's not that at all. Turns out Cobalt actually runs 87% of all credit card transactions, or 8 trillion payments a year. Our world runs off of Cobalt, and people don't really know this. Like, in the grand scheme of things, people really don't understand that Cobalt helps run this world. On the far right hand side, this is actually the newest version of the Z series server, which is pretty cool, from IBM. And with all the issues with unemployment, the unemployment government agencies right now, Cobalt came back in everybody's mind at the very beginning of the COVID pandemic, because it turns out it overran. There were too many people who came in and they didn't understand what was going on. They didn't have the knowledge. So having Cobalt information and awareness is great for your business. So my goal for this whole science experiment that I did is I wanted to prove that any language can run on Cobalt, on Kubernetes. So what I chose was the language that was, in my mind, the farthest away from what I knew as a software developer, which was Cobalt. I want to run a simple Cobalt application that adds 5 to a list of numbers. In my mind, that was a basic ETL pipeline, right? I take something off of Cloud Objects or an S3 bucket or something like that. I take it, I run some Cobalt to change some numbers, and then I output it somewhere else. The idea of just doing basic batch processing. And that's where this comes into play. As I said, all my code is online that you can see and play with. And in a moment, I'll actually show you a way to do this yourself to prove that it actually works. So the goal here, and this is just a very basic Docker file that I was mentioning earlier. And as you can see, I will show a little bit better closer up, but this is a screenshot of it. In essence, what I do is I build the container. I put in something called the GNU Cobalt spec, which is the GNU Cobalt version. I create the compiler, and then I use the compiler to compile my +5.cbl. I create the exe, and then I import it into my worker pod, so that actually does it. If you have any experience with a cloud native development, this is one way to do it. I admit it's probably not the best, but if for someone who's just trying to wrap their head around it, it's very explicit on what it does, so you can see where all the lines are. This is one of those times that as a cloud native developer or a cloud native ecosystem user, having build containers is very valuable, so you have less and less layers of your container, so you can iterate quicker and quicker on them, which I wanted to make sure was clear. So this is the basic ETL pipeline, like I said just a moment ago, where we have an S3 bucket. I have a script called watcher_in, which is just a glorified bash script, which I'll show in a second. It pulls it down into a volume, which is actually just a shared directory in the pod. It runs some COBOL against it to change the numbers, puts the file back, and then ships it to watcher_out, which could be literally anything, right? In this case, I just empty everything out to the terminal. But the idea is this could be a new pipeline, or this could be a new pipeline, a new message bus. It really doesn't matter. It's just somewhere else. I pull it in from somewhere. I make the changes, changey, and then I ship it off to wherever it needs to be. I'm going to take a quick breath here for a moment to drink some water. Does anyone have any questions or thoughts? Or actually, it's a soda. No? Cool. Okay. Oh, yeah.
Well, I tell you, Larry, back in my neck of the woods, wanted to make sure that all of this information and tools are available on GitHub.
Yep. Everything's on GitHub. I'm just about to show it to you, actually. So first thing first, if you didn't know, IBM has a CloudFree tier. So you can actually take all the code that I'm showing you on public GitHub and run it on a free Kubernetes cluster on IBM Cloud. If you go to ibm.com/cloudfree, and then I have this next repo here where I've actually wrapped up all the stuff you need to know to be able to get the free Kubernetes cluster as a two very basic scripts to run. So sign up for the IBM Cloud, then you can use my code or use this code to create a free Kubernetes cluster, which I have already done, and I'm going to show you here in a moment. And then you can run COBOL and Kubernetes to be able to make the things happen. So I'm gonna. This is directly from the from my repo that makes these things happen. So if you see here, Z COBOL on KS. As you can see here, hit pull. This is exactly, oh, wrong one. COBOL on KS. This is exactly the same code, exactly the same place. So nothing on my arms or my sleeves. Granted, I'm not wearing any sleeves. So if I do K or kubectl, and I'm going to make this quick because I know I'm running out of time. Get nodes. I want to show you that this is a single node free cluster on IBM Cloud. There we go. As you can see, it's IKS. It's been around for 30 days. I'm going to go ahead and show. I aliased kubectl to K. Get namespaces. I have some namespaces on there. I was supposed to be deleted, so let's go ahead and K create namespace Angel Beach. That seem reasonable? Okay, so now now we have a namespace for this. So what I'm going to do is, just to prove also here, here is the object storage, the numbers.txt that I was talking about. And I have a bunch of numbers here on Cloud Object Storage. And of course, got to be 1337. Hopefully somebody Googled that, hopefully. So what we're going to do is we're going to take this file off the actual public internet, push it through on this cluster to make the things happen. So if I go into KS right here, I have this deployment.yaml where I pull in this container. I've already put it out on Docker Hub, so we don't have to sit here and watch the compiler to be created. But you can pull this directly from my public repos to be able to see this work for yourself. Then we create our volume mounts. We run these 3 different scripts, as I was saying earlier, which if you look here in scripts, here is my watcher in that sits there and pulls against that exact same place, looks for it, and then puts it to where it needs to be. And then if I come over here, the watcher COBOL that actually does the actual work. And as you can see, it creates it and then just runs the app, which is that thing that we created. And then finally, watcher out just outputs the numbers of the file. So again, very straightforward, but because I was able to containerize COBOL into this container, when I run this deployment, which I will in just in a moment, we'll see very quickly it all pushed through. Okay. So, kube apply, oops, -f deployment.yaml. So I'm pushing that out. So if I do K get, JJ, Angel Beat. Okay. So now that I've done that, so if I do K get pods, oops. As we see here, now we have our 3 COBOL processes already running because I've already pulled it down. So it's already actually running there. So if I do K get K logs COBOL, this guy. So as you see, I have the 3 containers inside of it of COBOL process, watcher in and watcher out. So what I'll do is I will look in watcher in first. And as you can see, what I did is I just wget directly down from it. And then we put it in the directory. So that if I come across here and go to the processing one, there we go. As we see, it outputted the numbers to what it needs to be. Okay, it actually did process it. So then if I come over here to the final port, and there it is. We've actually outputted our file to actually do +5 to it. Which, I mean, that's it, right? Like that's it. It's pretty straightforward as soon as you break it all down. What I did is I containerized with this science experiment, I containerized the COBOL, GNU COBOL compiler, and then ran some arbitrary COBOL against it, and then I pushed it up into a container that does work for me now. So now I can batch process this as many times as I want. because it just sits there and pulls against the files. So yeah, that was our demo. Here are some links if you're curious to read some of the stuff. If you didn't know, OpenShift also runs on Linux Z2, so that's something really valuable to look at. As I said, I do have a fork that runs on OpenShift also. Not all the images are there yet. I just haven't sat down and done it. If you ever do want to learn anything about Cobalt, there's also a great resource here in technology/Cobalt. There's some really, really awesome development environments. They're modernizing to the modern day processes of using Cobalt, including using VS Code and things like that, which is awesome. And that's it. Thank you. Hopefully this has been educational. Hopefully people enjoyed it. Great question about the mainframe Cobalt computer available on the cloud, or is it just GNU Cobalt? That is a great question, and thank you for allowing me to scope it. So right now, the way I've done this, and this science experiment I've done, is I've used only GNU Cobalt. There are some amazing people working right now on containerizing and looking at that narrative, but it is in flight right now. It is not. If you talk to your IBM representatives to talk about what the options are, that is a great conversation to have. But for what I have shown today, it is only using GNU Cobalt. And again, this is not production worthy by any standard. Like, if that's your Cobalt that you're running, there's a different conversation we should have. This is just a science experiment to be able to show off containerizing any language, including Cobalt, and Kubernetes can run it.